Hello all, welcome to another tutorial from We Are Learning. Today we will be seeing about k-means clustering. I have already made a video on hierarchical clustering and explained the basics of clustering. If you have not seen, please go and watch that so that you know the basics of clustering. And now we will be talking about a k-means clustering, which is another methodology to do clustering. It is more about data segmentation. So you got a huge data and then you want to split it up into small clusters so that you can monitor it more, read them more closely, and take some crucial business decision on top of it. So what does k-means to us? So k-means, it is a methodology again which uses distance in this. Um, but how k-means works is like if you have somewhere around like thousands of data in your data set, right? It will try to take few examples as centroids first. Okay, maybe on the four columns, on the 4 points of the data, if you see an x and y column, and from there it will try to find the closest of it, right, and the farthest of it, and try to find a small cluster. And then the next time it takes another centroid unless and until all the distances that is trying to calculate has become to a mean value. This is what it does. It creates k clusters by assigning each example to the closest computed k new centroids, right? Then by averaging the examples in each cluster. This is what k cluster does. um, the best part is it just randomizes the data so you get the best clustering that you can have. It is very fast, it is very efficient. The only problem is when we are trying to derive the k clusters, you have to give the number of clusters that you want to see. If you compare with hierarchical clustering, you always had in the hierarchical clustering you could see that you would be doing a dendrogram which shows the number of clusters that you have, which is not the case in k-means. So you definitely need a business knowledge. We have other methodology to just compare and ensure that you are falling into a correct k clustering. Okay. Now that we know what is k-means clustering, right? Now let's try to run in a small data set and see how this functions. Okay. So you take your directory first and then you try to read the data set. I have used the same data set which I have used for hierarchical clustering, right? And then I see the first 5 rows. How does it look? This is the same data set that we used. So this is from a banking credit card section that we have seen how much an customer spends, how much in a single shopping, what is the probability of paying full amount, minimum amount, what is the credit limit, and what can we do to segment it, right? So then we try to see the data types, all are in the same data set, no categorical or different data sets. So it is good. It's a simple data set, right? And then we will see, do you have any null values? Do not have a null value, so no more data sanitation is required, right? So you will quickly try to see how many rows and columns, to 10 rows and 7 columns that you have, right? And then you try to describe. Here is where you see, the means are different that you see, right? And the columns, by columns you understand they all are read in a different scaling units, like spending can be in rupees, probabilities in percentage, right? Credit limit may have a different unit, so they have to be scaled before you apply the clustering methodology, right? So the best way and the most used way is z-score. So you just import the z-score from size SciPy stats and convert the df into a df scaled data set. Now, right, you applied, you see that, okay, and I want to validate that after scaling. Yes, my mean is almost equal to 0, my standard deviation is 1. That means now this has been scaled. Now these columns are somewhere similar to each one. Now I can apply a clustering methodology and see how this overall can try to give a segmentation for us, right? You just want to visualize it, you can see the box plot. Yeah, everything is near to 0 mean, standard deviation is in 1, looks fine, not much outliers. Now let's try to bring the k-means. So k-means you can see from sklearn, you bring the k-means, right? I want around 10 k range to see, right, in the cluster. And then to see, first of all, how much of maximum clusters it can happen, right? So that's why I've given a range 2 to 11, means it's 6 from 2 to 10 as such. K is always greater than or equal to 2 you can keep, so that you get a good k means, right? I've kept a random state that ensures that every time I just run this data, I get the same kind of randomized centroid it takes, so it does not differ. It is good if you're working on same data set multiple times or multiple people. It is good to have this random state. Yes. And then I'm trying to fit this, and then I'll tell you about what is WSS, right? So, okay. So now what is WSS? WSS is the squared value that you see, and it will give an inertia for us. What does this inertia means? This is somewhere you can call it as the variance that you see, right, from the within sum of square of the WSS. How much of variances it can happen, right? If I make a 2 cluster, it's saying it is 659 is my inertia. If I make 3 cluster, it is 430, and if I make 4 cluster, it is 371. If I make 5 cluster, it is 326. The difference between 2 and 3 is huge, from 659 to 430, whereas 3 to 4 it falls very lesser, and 4 to 5 very lesser, and keeps on goes lesser. So such a close variance does not make much sense for us. So by this inertia methodology, you would see that maybe 3 cluster is ideal for us, correct? But I would like to validate, because applying k means you have to give how much clusters that you want. So I probably thinking 3 should be better, but can I do some other methodology to understand whether it is correct or not? Correct. So for that, we will use the elbow plot. Elbow plot, what does it do? It gives a visualization for you. You can see I'm trying to bring the same range, right? And I've given the colors, I've given the methodology as elbow in the plot, right? And it will try to give the cluster. So if you see after the 3, that's where you see the elbow, correct? And after that, it goes almost straight for us. So 3 is a good way of taking a cluster, which you see in the visualization as well. So I can bring the cluster to be 3, the k-means, right? And I make the same random state and try to make it as a cluster. So you can see in the array that you can see 0 is the first element in the data set forms to a cluster 0. The second element goes to 2 as the cluster, the third element goes as 0, and the fourth element as 1. So 0, 1, 2, so you have 3 clusters, right? As I told you, one disadvantage in k cluster is I have to give a cluster, correct? How many clusters I want. And with the limited knowledge of business, I can say with the elbow method and the inertia method, you can see 3 is optimal. But suppose if you are not an SME, right, and you do not want to take this as the final value, you can always go and try to use a siloed score. Okay. Now, what is siloed score? I will explain you in little detail. First, let's import this siloed score, right, and apply it to our scale value. And you can see it is 0.40 is the siloed score. So siloed score always values from -1 to +1, right? -1, then you have a wrong cluster. 0 means no variances between the two clusters that you're trying to see, and anything goes to positive, it is a good clustering that you're having. Okay, that's what siloed scores means to us, right? And I'm trying to find what is the silos width as well. So it is trying to see how much width between the clusters it is showing, right? And you can see all are positive, correct? And I'm trying to see what is the minimum. Minimum is 0.0027, so there is no negative value, means there is no wrong clustering, correct? And there is no 0 because the minimum is 0.002. Now let me tell you in little more deeper what is siloed score. So what it does measure the distance of one point from another point, right, of the same cluster, and which is called cohesion. It uses cohesion and separation methodology. Okay, cohesion is it is trying to make the similar elements as one cluster, and separation is trying to separate the one cluster, the one point in that cluster from another point from another cluster. So it uses cohesion and separation. So when it is doing a cohesion, we will take it as an example A, for instance. Okay, And the same point which was used to do a cohesion, the similarity between a cluster, I'm trying to find the farthest value from the other cluster and ensure that that becomes a B for me. Okay, so this is first you got a and then you got a B, right? Then what is Silhouette score? The farthest value and the nearest value divided by the maximum of A and B. This formula works out to be an answer between -1 to 1. So if you get a -1, it's a wrong clustering, right? 0, there are no much difference between both the clusters, so you're not doing it right way. And if it is anywhere between 0 to 1, then they are far away to enough so that you can consider them as a clustering. Since the minimum value is positive and obviously it will be less than 1, we could consider that 3 clustering that we are doing is fair enough with what we derived from k means, and we can opt this value. Means I'm making a label now, a new column, k means cluster, and calling it as label 3, right? And I'm trying to group by means and make them as a cluster. Now you can see 0 is one cluster, 1 is another cluster, and 2 is another cluster with different sets of means. It has 18.5, it has 11.85, this has 14.43, correct? And now this has made a cluster. It gives the total count. This again come to 210, which is the total rows that we had, right? Now that we have 3 clusters optimal decided by the elbow method, and you just cross verified with the Silhouette score, it looks optimal for us. It was very quick. It can handle very complex, very big data set k-means. Recent past, there is another concept called k-medloids, which is also another concept which says the variance can be identified much better using medloids, which is more of a median concept it uses. But most widely used k-means, it's very quicker. The only disadvantage is like we have to give a cluster, which you have to decide either with the help of an SME, or you may use different other methodologies, like you apply the same thing to the hierarchical methodology and see, okay, this also give 3 clusters, k means also 3. Okay, fine, the clustering that we understood to stop with 3 is optimal. That's how we have to take it forward. And you can use any example data sets that you have, try to apply this segmentation, right? Ensure you sanitize the data, you have scaled it if it requires scaling, right? And then apply hierarchical or k-means and see how good you're able to cluster it. And once you have the segmentation done, then business can use it in various different ways to improve their business, recommend new product, retain customers, which customer is more likable to go away from us, so how we can bring them in, or which customer are like underutilized, so we can do more offers and make better business out of them. Segmentation, clustering is wonderful with using these kind of methodologies, and I hope that will give a lot of insights for you when you get a data, and maybe that can be the base for you to do or more analysis, or you can do more predictions. Maybe some other models can be applied once you're done your segmentation. So that's all in this tutorial. I hope this is of help. Try to practice more, learn more, and I hope this is of useful for you. Thank you.